In this video, I'll talk to you about R programming. In our project, R is a language and environment for statistical computing and graphics, and it provides a wide variety of statistical techniques such as linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, etc., and also graphical techniques, and is highly extensible. And it's available as a free software under GNU General Public License. You can program R in RStudio, and RStudio is a free and open source integrated in development environment, or you can call it shortly IDE for R, and it is available in two editions: RStudio Desktop and RStudio Server. The desktop version runs locally as a regular desktop application. The server application allows accessing RStudio using a web browser. The distributions of RStudio Desktop are available for Windows, Mac OS X, and Linux. You can follow the links here to download RStudio and R. First, let's talk about R operators. This is a list of operators. We have minus, which can be unary or binary. Plus can also be unary or binary. Not and tilde that is used for model formulas can also be unary or binary. Help, sequence, multiplication, this is binary. Division, exponentiation, modulus, integer divide, and matrix product. In the second page, we have outer product. We have Kronecker product, matching operator, less than, greater than, equal to, greater than or equal to, less than or equal to, and this actually for vectorized form, and this is your non-vectorized form, or for vectorized and or for non-vectorized. Left assignment and right assignment, we will see this in examples, and also list subset. Let's look at several examples with operators in R. So in R, in order to create a vector, you use C, this C function, and give it the elements to start to initialize the vector, and then use the left assignment operator to assign to store the result onto X, onto the variable on the left. You can switch the order. You can switch the order and use the right assignment instead. So once you do this, you can type in, for example, X, and then it shows you the content of X. In R, you can use the semicolon or simply a new line to separate statements. Okay, if you write X greater than or equal to 3, then when it runs, this returns a vector of false and true values, and you see false where the elements actually do not meet the condition, and true otherwise. Similarly, if you say you type in X not equal to 3 and enter, then it returns you a logical vector containing true and false value, and you see true where the elements actually meet the condition and false otherwise. You can combine conditions using OR, right? And like this. You can create, you can use the colon or sequence operator to create a vector with elements that are consecutive numbers. So this means that create a vector with elements starting from 1 up to 4 consecutively. So it's going to be 1, 2, 3, and 4. If you form a condition, let's say this is a condition that you form, and then you give it to a vector x, then it would return the elements that meet the condition. So actually they are 1 and 4. You can create a matrix this way. So first you create a vector using the sequence operator, and then you say you want 3 columns. So you call the function, you tell the function that you want 3 columns, and it create a matrix for you with 3 columns and 2 rows. This is another way, and in this example you create a matrix with negative values in the elements. Let's talk about data types. R has a wide variety of data types, including scalars, vectors, matrices, data frames, and lists. So we talked about how to create vectors using the function C, right? And we can also combine uh, vectors in vectors. So here we combine vector x and 0 and also x again to create a new vector. You see here, right? This is x, this is 0, and uh, this is x again, and the whole thing here is a new vector. You can use the sequence operator to create vectors like this. And you don't have to always to use the left assignment. You can also use the right assignment like this. And in addition to the colon, you can use the sec function. Right? So create a sequence from -5 to 5 with a step of 0.5, and the result is stored in W using the right assignment operator. So you can see if you use the sec function, then you start the first parameter is the start and ending value and the step, right? And you can also use length and the starting point, the starting value and the step. And if you do so, then maybe the good thing is to specify to tell which parameter and which value explicitly. So the length is 21, from is -5, and by, which is the step, is 0.5. We also talked about logical vectors, and actually the result of logical operators is a logical vector with false and true values like this. There are special values in R, which is NA, meaning not available, and NaN, which is not a number. So if you create a vector, and in the vector you have an NA value, and if you check using is.na function to check if there is any NA value in a vector, then as you can see, it returns true right at the element that the NA value is, and false otherwise. And similarly, if you store 0 divided by 0 to C, then C is NaN, which is not a number. And if you check using is.nan to check if C is really NaN, then the result is true. In R, you can use the paste function to concatenate strings. You can also use paste function to create character vectors like this. So the first parameter is a vector containing one element x, which is a character, and the second parameter is a vector containing elements from 1 to 8, and you specify the separator using the sep parameter. The separator is a hyphen. Then it creates character vectors like this. So x with the first element and the separator between them, that is the first element. So x1, x2, x3, etc. up to x8. Elements with a positive size means element inclusion. So if you say x 1 to 2, then the result includes the first and the second element in x, which are 1 and 2. But if you have the negative sign, like let's say -1 and -2, then the result in P actually do not include the first and the second element. So if you look at P, then P contains 3 and 4, and there are no the first and the second element in here. The next type is matrices. A matrix is a rectangular table of data of the same type. So if you want to create a matrix, you call the matrix function and give it the data. The data here is a vector with elements from 1 to 10, and say how many rows you want and how many columns you want. You can just give it 5 and 2, right? And that's enough. And if you want to explicitly tell which parameter goes with which value, you say then you say n row equals 5 and n col equals 2. And if you say this explicitly, then you can switch the order. It doesn't matter. And this is the result. And you can see there are 5 rows and 2 columns. The next type is arrays. Array is multidimensional, and in order to create an array, you call the array function. So here you call the array function and give it some parameter. The first parameter is the data. Here you say 1, just 1, so it contains all 1. And the second parameter is a vector. Specify the first dimension, the second dimension, and the third dimension. So basically you have two let's say 2 arrays on the top of each other, and each array has a size of 3 by 4, right? So it's 3 by 4, and you have 2 arrays like that. In the second example, you give array different kind of data. You give it a vector, and this vector contains 1, 2, 4, 5, 3, 6. So basically 6 elements. So as you can see in the result, you have 6 elements here, right? 1, 2, 3, 4, and then 5, 3, 6. And because you still have 3 rows and 4 columns, right? So you still have to repeat that, the same data 1, 2, 4, and 5, 3, 6. And similarly with the second array, Next, we talk about lists. A list consists of an ordered collection of components. A list may consist of numeric vectors, logical values, matrices, character arrays, etc. In the first example, we call the list function to create a list with several components: ID, name, and sex. So there are three components, and the list is stored in CEO list. And if you type in CEO list and enter, and it shows you all the components. You can use the list operator, which is a $sign here, to access the list components. So CEO is a list, and you type in the $sign and the component name, then it gives you it refer to the component ID. You can also use the index of the component. So let's say if you type in CO list and say you want the first component like this, and the result returned is the same. You can also use this form. And similarly, you want to access to the component name, then use the list and the $sign and then the component name. If you want to add a new component, then use this example. So here I specify the new component the same way, and store a vector of company names to it. There are three company names here. Okay. Then you look at if you type in CO list and enter, then it shows you all the components, including the new component. And if you access to the new component, then use this CO list and the $sign and the component name, then it shows you the content of the new component. If you store the value now to a component, then it means that you want to remove the component from the list. And if you do so, then when you list all the elements, then you don't see ID, the component ID anymore. You can take the length of the list using the length function, and length of CO list would give you 4. And the length of 4 here is when you have 4 components, and if you have removed one of them, then it would give you 3 instead. Next, we talk about data frames. A data frame is used to store data tables. Basically, it is a list of vectors of equal length. And now we look at several examples. We create a vector with 3 elements and store it in X, and another vector with 3 elements with some names and store that vector in Y. And then we call the data frame function and give it X and Y. And we give 2 vectors of the same length to it, and the result is stored in a df, and then when we look at df, we see this is df. It looks like a table, right? And this is actually a data frame with this is first and that is the second column that made from the 2 vectors. And basically you can convert a list to a data frame. So just call data frame function and give it a list, then it convert each data frame. So this is an example, right? If you give CO list to the data frame function, then the result will look like this. You have here name, sex, and company. So those are the list previously. I'm sorry, the components in previously in the list, and now those make the data frame. Next, we talked about the filters. A filter is a filter object used to specify a discrete classification. So if you have categorical variables, then the variables have to be filters to be used properly in statistical modeling. Now we have a look at the example. So first we set the seed so that the result is reproducible, and then later use sample from a sample of numbers from 1 to 3. So basically we have three numbers 1 2 3, and you pull from the sample 20 times with replacement, and the result is this. The result is this. Then you create a filter variable, namely norm category, using the function filter. So num category previously was created with all numbers here, but then you give the labels to the numbers. So number 1 is gonna be Setosa, right here. Number 2 would be versicolor, and number 3 would be Virginica. And when you look at norm category, you type it and enter. It gives you content of the filter, and you look at the filter and you see the content. And now treat this variable, this norm category, as a nominal variable. So you use filter to create or to convert to nominal variable, right? And you use ordered for ordinal, right? So if the values actually have some order, then you got to use this function order, okay, order, to convert into ordinal variables, and otherwise use filter to convert into nominal variables. And if here you want to check, if a variable is a filter, then you use this function is.filter, and it returns true for norm category. And in the printout here, you can see there are three levels: Setosa, versicolor, and Virginica. Three levels, three categories, three classes, same thing, right? And the function levels given a filter would give you the number of levels or the number of categories. So if you create a vector, right, you use the C function to create a vector with the existing levels, and you also add new levels in, right? And then again use the filter function and the first parameter is norm category. Then now norm categories becomes having one more level, which is others. And if you look at norm category, then you see others as a new level. You can measure the length of a filter using the length function, and you can add new elements to a filter. Okay, so here you add others to element 21 to the 21th and the 22, so I mean 21st and 22nd elements. Then you have them here. And next we talked about control structures in our programming, and control structures are very useful, actually necessary for programming. The first structure is if. So this is the syntax. If condition. If the condition is true, then you run statements, and else, meaning otherwise, you run some alternative statements. And this is the example code. You create a vector with 4 elements, and you call the function any x greater than 4, right? You check if there is a element in x which is greater than 4, then it returns true. And then you enter a if structure, right? If any x less than 0, then you store true, okay, in the variable y, and otherwise you store the boolean value false in the variable y. So when you run this, then y returns false. The next structure is for loop. So normally you use for when you know the number of iteration that you want to run. So the syntax is for name in expression, and run the statements. So let's look at some examples. In this example, for I in a vector from 1 to 10 with elements from 1 to 10, and print what? Print I times I. A simple example, and this is the result. So basically I would be in the first iteration I is set to 1, right, to the first element, and then print 1 times 1. And then in the second iteration I is set to the second element, which is 2, and it print 2 times 2, and then it gives you 4, etc. The next structure is while loop. So you use this while loop when you don't care much about how many times you have to run, how many times you have to iterate through the loop. It's just a loop again and again until again and again until the condition, as long as the condition is still true. So the syntax is while the condition is still true, then you run the statements. This is the example, right? You set initially, you initialize I with 1. You can use this form, or you can use this form, right? Same thing. You store 1 to I using the left assignment. There's several ways to do so in R. So while I still less than or equal to 10, you print I times I. And then take the square root of I, and then add it to I, and then store the whole thing again in Y. In I, and loop again and again. The last structure is repeat loop. So we repeat again and again. And this is the syntax. Repeat what? Repeat the statements. So this is the example code. You initialize I with 0, and then what? You repeat doing something, right? Repeat doing something. Increase I, increment I at every iteration, and then check if I greater than 10, then break. So you use it to break the repeat loop. And here you use the cat function to print the value of I, and also after printing you want to enter to the next line. You print I to the screen. And next we talk about how we can write your own function in R. This is the syntax of user-defined function. So you go with the name of the function first, right? And on the other side of the arrow, write a function and the list of arguments that you want to pass. You pass to the function, and then the list, the expression, and the result, the returned result. You want to return a variable from the function. This is an example. You define a function, namely square, and the parameter is x. Here you calculate x times x and store the result into z, and then you return z from the function. So once you define a function like this, then you can call to the function. So here you call the function, you call the function in the name of the function. Okay, square is the name of the function, and you give it 4. So basically you want to ask the function to do something for you, and it's gonna take 4 and return 4 squared and store it into R. So later on you look at R, you get 16. Right? You can see the equal the assignment here, and you also use left assignment or even right assignment. Now we talk about R functions. In R you can use so many functions provided by third parties. So in order to do so, you need to first install libraries or packages. So in R you're gonna install packages, and later on in your code, before using any functions from a library, you have to use this syntax: library or require, and then give it the library name, and later on you can use the functions in the library. Next, look at a few useful file functions, IO functions. For reading and writing to Excel files, there are a number of functions. For example, load workbook, read worksheet, write worksheet, and write worksheet to file. This is an example. You require the XL Connect library, and this is for loading, writing, reading Excel files. So once you do this, later on you can call the load workbook. Load workbook, you give it an Excel worksheet stocks.xlsx and store the result into WB. And later on, if you want to read data from a specific worksheet, then you call the function read worksheet and give it the workbook object WB, and then the worksheet you want to read from, in this case it is sheet 1, and you also want to specify to say that there is a header. Okay, so that the function knows that there is a header there. You can just use sheet 1 here and choose there. But if you want to explicitly say which parameter goes with which value, then you use this syntax. And if you use this syntax, then actually the order of the parameter pairs not important anymore. You can change as you like. For CSV files, you can use the write.csv and read.csv functions. So CSV files actually are just text files with the delimiter comma, right? So between fields in CSV files, commas are used to separate between fields. Basically, CSV files are just simply text files. So write CSV, write what? My data is a variable that you want to write to the CSV file. Write to this file, okay, and then you clear the memory. Use this syntax to clear memory, clear, remove, remove, uh, remove all objects, right? All the objects is passed to the list parameter of the rm function. So this is the way that you pass parameters explicitly. Also here, right? You specify the parameter names specifically. So once you have written the data to the CSV file, and you clear the memory, and you later on, if you want to read back the data, use read.csv, right? read here, read from data.csv, and store the result into my data. You can also use write.table and read.table, and this is the example code for writing and reading data frames. Next, let's look at a few graphical functions in R. So just like what you did in MATLAB, in R there's also a plot function. Plot what? Plot y against x, right? Or just plot y against the indices. This function plot the histogram of x. This is an example for plot function. Dev.new, create a new device, new figure to plot, right? And then create a vector using a C function and store it into cells. And cells is a vector, right? And then plot cells. So the plot is created and with the color blue without any annotation, and also you can give it the main title, right? X label and Y label. And to summarize, we have gone through the basic programming in R, and I now just want you to look at the code and try the code, look up the code and try it in R and see how it goes. And that's for now, and happy coding.